Okay, so if we rewrite this, you would have, if you were to label it, it's a alphabetical logbook on the pirate ship. And then we're going to rewrite it. He says, I see a B. Must be getting close to shore or something. Well, my A is, my A is a third. C is what's going to come next, and it's my missing thing, X. And then my B term is this 243 up here, isn't it? Right here. Okay. So the key to these, and y'all did a few of these in some of the exercises, I don't know if you remember them or not, is what I want to do is I want to think, okay, I know a third to the x power. Couldn't I think of this as 3 to the negative x power? Right? Because if it was a third, let me put another step in there. If it was a third to the x power, let me put another step in there. Isn't a third the same thing as 3 to the minus 1 power, right? Okay, so this would be like 3 to the minus x power if you multiply those exponents. I kind of skipped that, but it might not be so clear. Now, 243, it's probably 3 to some power. I know that, so let me start with what I know. I know 3 to the fourth is 81. So if I multiply by another 3, which would be 3 to the fifth, right? If I multiply by another 3, 3 times 1 is 3, and 3 times 8 is 24. Oh, isn't that what that is? 243 is equal to 3 to the fifth power. This is one of the reasons why at 6.5 on number 1, he had you make all those lists. Sometimes if you kind of make a list and keep it with you all the time, or you remake it every time, a good thing about remaking it every time is you start learning the numbers without having to look at it. So when you see something like this, usually you're going to try to write the other number in terms of the, you know it's not going to be in terms of 1, so let's try it in terms of 3 and see if we can't manipulate it a little bit. So 3 to the fifth is 243, so it must mean if these two expressions are equal, then it must mean these two exponents are equal, right? So negative x equal 5. If I divide each side by negative 1 or multiply each side by negative 1, I'd get x equal negative 5. So a lot of the times on these, you're going to be rewriting things in terms of the same base when you kind of maybe at first go, I'm not sure where I go with this. So far we haven't done the change of base formula at all, so maybe I'm off on that. For some reason I was thinking we were going to get into that today. Usually those are the tricky ones. Okay, so log x 81 is equal to 4/3. Okay, so let's label this. Again, you don't have to label it if you see that you're supposed to write x to the 4/3 power is equal to 81, but if you don't see it, go through the process. Eventually, after you do this enough, you start seeing how to do it without this little memory device. So I'm going to change it over to the other form so I can try to think about it because I don't know anything about this when I look at it. So my x is, let me see, my A is x, right? My C, which comes next, is this 4/3. And my B is 81. Oh, this is cool. I'm glad you asked this question. Okay. If I have this equation and I want to solve it, how could I get x by itself over here? I'm going to do something to both sides. This is the first time y'all have ever seen this pop up in this class anyway. Maybe you've done it before. If I'm solving for x, isn't that x to the first power that I want to get, right? How could I turn that 4/3 into a 1? Do I know any exponent rules that might help me do that? What about this? What if I had it raised? What if I raised both sides to the 3/4 power? Don't the exponent rules say, well, power to a power you multiply, right? So if you want to make a 1, why don't you can basically raise each side to the reciprocal exponent that you had on the x in the first place. See how I flipped the 4/3 and I got 3/4? Wouldn't the 3's cancel out because you multiply them and the 4's cancel out on this side, and wouldn't it leave me with x to the first power? That's how you handle these. And on the other side, I can figure this number out because I've got, remember this is it's raised to a fractional exponent, so remember that I look at the denominator first. I'm going to take the 4th root of 81, and once I find it, What am I going to do to it? What does the top exponent tell me I'm going to do? Or cube it, right? Remember, it's cube. So I used the fact that I could, when I raise a power to a power, I multiply them. I used it to get x to the first power in a weird kind of way. And now that I did it, remember, if I do it to one side, I got to do it to the other side. It's the same thing. As long as you do something to both sides of an equation, you kept it equal. The 4 through to 81 is just 3, because 3 to the 4th power is 81. You could have put that part in. Actually, you could put all this in your calculator once you get it looking like that. But just let's kind of make sure we're getting some math skills, math literacy built up here. The 4 through to 81 is 3, but then when I take it and I cube it, I get x equal 27. I could label this, but if you remember how this kind of works, and we talked about there was a little, you could do a little muscle memory thing. It's the x to the 0 power is equal to 2. I could label it ABC. Write it as I see a B, but I'm going to get the same thing. I'm going to get x to the 0 is 2. So hopefully, eventually, you get used to doing it without the memory device. I'm usually okay going this direction with it. I'm not usually okay going backwards with it without the memory device. What is anything to the 0 power over here? 1. Does 1 equal 2? No. Is there an answer to this problem? No, there's no solution. No answer is what he writes. Some of these problems, again, he doesn't give you easy problems. So if you're thinking, how is I supposed to know to do that? I understand. I wouldn't have, except I'm the teacher and I've done it too many times to... That's not a negative 3/2, it's a positive 3/2. Always make sure you're looking at your book, just because, I can't always control how the iPad's picking this stuff up. So this is log x of 1 over 216 is equal to 3/2. So again, if you're not used to doing it without the memory device, or you haven't quite figured it out, you can always label it and say that's I, C, a B. And I still don't want to go, obviously, this is x to the 3/2 power is 1 over 16, but some of you may feel that way. My A is my x. My C is this 3/2 over here. And my B is 1 over 216. Okay? Well, that's weird. How am I supposed to know what to do? What did we just do in the last, I think it was a recent problem? How am I going to get x by itself and be x to the, because x by itself would mean x to the first power. How did I get rid of that exponent? Y'all remember? I did something to both sides. Remember what it was? Yeah, that's a fractional exponent. It's 3/2. If I raise each side to the 2/3 power, wonderful things happen over here on the left. The 2's cancel out and become 1 and 1. The 3's cancel out and come 1 and 1. And pretty soon what I'm left with is x to the first power is 1 over 216 to the 2/3. And he's had you practice that before. So hopefully your brain kicks in at this point and goes, oh, I'm supposed to, here's really what you should do. Let me break this into little smaller pieces. The 2/3 goes with the 1. The exponent goes with the 1. It also goes with the bottom part, doesn't it? But 1 to any power is still 1. So I'm looking at 1 over 216 to the 2/3 power. It doesn't matter that that's 2/3. If I take the cube root of 1, I get 1, and then if I square it, I get 1. So it's 1 on top. And then if I think about it, this fraction is telling me, remember how we always do the denominator first. I'm going to take the cube root of 216, which I think is 6, but I'd probably like a calculator to check that. And then when I get done with that, the top part tells me I'm going to square that answer. It's 36 times 6, 216. Everybody, is 6 cubed 216, I think. Let's say it is, I think it is. And so the cube root of 216 is 6, and then I square it, and I get 1 over 36.